So, before explaining more about um, coroutine, how coroutine works internally, the main loop, how main loop switching the control. So, before explaining this topic more, let me just explain the structure of a coroutine. So, here what you are seeing is a structure of coroutine. So coroutine is supported by asyncio module in Python, and they have two keywords mainly to support coroutine, that is async and await. So if there is no async keyword, uh, it will be ordinary def, means ordinary function. It will be ordinary subroutine. So async keyword instruct Python interpreter that this is not ordinary subroutine, or this is not a ordinary function, but this is a coroutine. And they have one another keyword, um, await. So await can only be used inside a coroutine. It cannot use inside a um, ordinary subroutine, or it cannot use from inside an ordinary function. So await can only be used from inside a coroutine. So await tells the interpreter to suspend or to wait the execution of the current coroutine and pass the control to um, some other coroutine or main event loop. And you can see they have two coroutines here, and what you are seeing here is a event loop. This is one of the very simple event loop. So from inside this coroutine also you can see it is using asyncio.gather. So here you are calling this particular greet coroutine three times with three different arguments. And here also we are using one another event loop. Gather is actually a event loop. So we can organize our coroutine. It is very flexible, and we can organize our coroutine as we wish. So event loop is right. This event loop asyncio dot run. This is actually running an event loop. This event loop is uh, switching the coroutines. Right. It will help Python interpreter to switch the control between the different um, coroutines. And when it will switch, when the control is reaching an await statement, it will suspend the current operation. It will suspend the current operation, and it will move the control into the next waiting coroutines or to the main loops. Okay. So I'm stopping it here. I will explain this structure more in detail, uh, but let us jump into the next slide. So in this slide, I am going to explain event loop a little bit more, because it is very important to understand the event loop, its structure and all, to understand the coroutine, because uh, event loop is actually manages different coroutines. So understanding event loop is very important to understand the concurrency uh, using coroutines in Python. So I'm going to explain different structures and of event loop. So as you can see, this is one of the very simple coroutine, and we are creating an event loop here. What you are seeing here is an event loop. So event loop is created using this asyncio module, asyncio module dot get event loop, which is actually returning this method is actually returning a loop object, event loop object, and it is calling run until complete and adding this coroutine. Actually, when you are calling task, uh, this is a coroutine, so it will not directly run uh, the instruction inside it. It will return a coroutine object. Calling a coroutine um, like this, right? Calling a coroutine like this will actually return a coroutine object. So this task method calling is actually returning a coroutine object. So it will be an argument to this run until complete method of event loop object. So this loop object is actually looping, and uh, it loops through different coroutines, and whenever an await is coming, it is switching the control to other coroutines. If they have other coroutine, it is switching control to the other coroutines. And again, one another await is present in that coroutine, it will switch the control to the next, or it will be looping. So event loop is actually responsible uh, to run the actual coroutine instructions, wait or pause it, and when the await statement is visible, and switch control to some other coroutines. And there also, if some await is there, then control will switch back to the previous old coroutines, um, and so on. So this is how coroutine is working. So once all coroutines completed its execution, it will go to the next line, and control will be completed. So you can see this statement. This is one high level type of function run that actually internally calls, you can imagine it is internally calling these three statements. So these are two different methods of calling uh, event loop, running event loop in Python. They have many other ways also. Mm, and they have third-party libraries that implement custom event loop depending on various situations, and depending on various uh, implementation requirements. They have some other third-party libraries that support enhanced uh, event loops in Python. So in this slide, I'm going to explain a little bit more about the event loop. So I'm trying to explain what is actually an event loop, how event loop is handling multiple coroutines concurrently. So I'm not going to import asyncio. I'm not importing asyncio module here because I want to show you how an asyncio module internally manages an event loop. So I'm not importing, or I'm not using any um, built-in event loops. I'm using my own custom event loop here. So this is a custom event loop I'm using. That custom event loop I'm initializing here, and I'm adding two coroutines, worker 1 and worker 2. You can see worker 1 and worker 2 here. Two coroutines here. I'm adding this worker 1 and worker 2 into my event loop. So as you know, when I'm calling an event loop like this, it is not like ordinary function. So when I'm calling like this, it will not execute the statements, right? These statements will not get executed. Normally, when you are calling a function like this, the statements will execute one by one. But when I'm calling a coroutine is specified by this keyword. So when I'm calling a coroutine like this, um, it will return a coroutine instance. That's how the underscore underscore call underscore underscore, right? That special method is designed inside a coroutine. So when I am calling this uh, coroutine function, uh, it is actually returning a coroutine instance. That coroutine instances I'm passing to here, add a task, right? So I'm actually adding these coroutine instances to this event loop. So in this event loop, I have a queue. It's a list type of data structure. It is a queue actually. So I'm adding both of my coroutines, this coroutine and this coroutine, into this queue. You can see I'm appending it here. After that, I'm calling the run statement, run function, run method of my event loop. So it is reaching here. So when I'm reaching here, I already have this queue populated, task queue populated. It is having all the coroutines. So I have multiple coroutines in my task queue, and I'm going to run my event loop. So event loop is nothing but an loop. You can see a loop. I'm looping through all the coroutines in my queue. So this is my task queue. So I'm in this loop. I'm looping through uh, all of my uh, all of my coroutines. So I'm looping through all of my coroutines like this. So how I am doing? I have a queue and I am popping out the first queue, first coroutine. This is the first coroutine, right? Because this is a queue. First coroutine means this one. So I am popping out the first coroutine and calling it. This is how I am calling that coroutine. So coroutine instance dot send. So if you know the generator, Python generator, iterator and generator concept, right? So if you know the Python generator, new style generator, then you know that you can invoke a generator using this statement, generator.send. So that's why they have a lot of relationship between a coroutine and a generator. Actually, a coroutine in Python is a generator that I will explain. So here I'm invoking my first coroutine. So what we are trying to do in this loop, this loop manages multiple coroutines at the same time. This event loop is the loop that manages multiple coroutines at simultaneously. It runs multiple coroutine simultaneously. So I'm going to explain how it is sending multiple, how it is running multiple coroutines at the same time. So it is popping out the first coroutine and invoking it, task.send. So uh, this will invoke the first coroutine. So first coroutine have the print statement. So this will be executed. Next one is an await, right? So when the control is seeing this await statement, the control will be paused here. Control will be paused here, and the control will return to the next line of the caller, next instruction of the caller. So control is paused here, and here you can see the current coroutine is pushed into the tail end, and next coroutine is popped out. So this is the next coroutine, and again I am invoking using the same method. I am invoking the second coroutine. So this will be executed now. So this statement will be executed again and await. So control will be paused here. So this is how, so you can see the first coroutine is invoked and control is posed here, and the next coroutine is called and control is posed here. Then again, when this loop is executing, uh, you can see this second coroutine is also pushed into the tail end. So again, the first coroutine will be popped out. That will move into the first. So again, I am invoking this one. When I am again invoking, it will resume from previously posed location. So it will resume from here. So it will move into the next instructions, right? From here. So you can see now the two coroutines. One coroutine is posed here and the next coroutine is executing from this line onwards. So two coroutines are simultaneously working now, and even loop. This type of simple even loop itself is able to manage multiple coroutines at the same time. And once the control is reaching at the end of any of the coroutine, uh, it will raise a stop iteration error. So when it is reaching the stop iteration, um, as you know, that coroutine will not be added into the tail end again. So coroutine, this event loop will run using the remaining coroutines. Finally, this queue will be empty and the run will be completed. So this is how it is working. This is how a multiple coroutines are working at same time. Additionally, you can see a lot of similarities, right? You can see a lot of similarities between a coroutine and a generator. So you have to understand when an await, right, an await statement is called. You can see I'm creating an instance of this class, and when an await is invoked, this await special operator will be invoked actually, and it is calling a yield statement. So await yield control instance means it will be actually replaced by a yield. So yield, when you are putting a yield inside a function, that function is actually becoming a generator. That's why you are able to pose your control and return into the crawler and resume the instruction. And again, now when you are invoking um, that coroutine, you are resuming from your previously posed location. So this is the exact behavior of a um, generator. So why it is showing the behavior of generator? Because await yield control is actually yield control is a coroutine. Yield control is a coroutine instance. How it is becoming a coroutine instance? By adding this special operator. This special operator is actually running a yield statement. So when you are invoking like this, the final statement executed will be yield. So yield will replace this one. So um, that is why um, that is how this function is converted to a generator. That's why I'm telling this coroutine is actually internally um, a generator. Coroutine internally is actually a generator. So an event loop is nothing but an loop, ordinary loop. That loop handles multiple uh, multiple generators. So internally, event loop is actually an ordinary loop that handles multiple generators. Coroutines are internally generators. So you saw how these generators, because generators have the ability to pause the execution and resume. So it is pausing the execution when yield is visible present, and it is passing the control to the caller, and when again, right, again it is invoked, the generator is invoked like this, it will resume the control from the next position. So this is how Python is implementing concurrency. So Python is implementing concurrency with the help of this type of an event loop, and that event loop manages multiple generators, so generator type of functions. So that is the concept. And when you are putting async, right, async in front of any function, it is actually internally adding this one await, and it is converting it to the function is actually converting into uh, a coroutine. So that's all about it. We covered a lot of concepts here. So I will show a visual representation of this loop, this simple event loop in my next slide.